Hi, this is Pravalika. We are going to explain to you all about COVID-19 face mask detection using CNN. We are three members in the group, Sam Pratyusha, Ubani Samson Raj, Kashabena Pravalika. And these are the contents are like abstract objectives, convolution neural network, importance of the project in the context of current situation, CNN architecture from the workflow, Hardscape, and expect outcome and results and references. And we have know that introduction, like we all know that coronavirus has an havoc on global health. So it's very important to protect us from our surroundings. While going outside, wearing a mask is a must and should for prevention. And this study investigates a method whether a mask is put or not in workplaces, offices, etc. In this, we have used convolution neural network to do the same. And we have the main objective of this research is to identify a person whether he or she is wearing a mask or not on image or video. And before going to the deep into the research, we need we should understand what is CNN is. And CNN is a convolution neural network is a type of artificial neural network used primarily for image recognition and processing due to its ability to recognize patterns in the images. A CNN is a powerful tool but requires millions of labeled data points for training. And in this, we have three types of layers like convolution layer, polling layers, and fully connected layers. In convolution layers, and this is the first building block of CNN, a name suggests that the main mathematical task performed is called convolution, and which is the application of like sliding window function to a matrix of pixels representing an image. And we have seen here like the sliding function applied to the matrix is called kernel or filter, and both can be used interchangeably. And this in these convolution layers, several filters of equal size are applied, and each filter is used to recognize a specific pattern from the image, such as curving of the digits and the edges and the shape of the digits and more. And the polling layers function is that like the goal of the polling layers is to pull the most significant features from the convoluted matrix, and this is done by the applying some aggregation operations and which reduce the dimension of the feature map and hence reducing the memory used while the network. And pooling is also relevant for mitigating and overfitting. And the most common aggregation function that can be applied for three types like max polling, sum polling, and average polling. And max polling is the which is the maximum value of the feature map, and sum polling corresponds to the sum of the values of the future map, and average polling is the average of all the values. And the third one is the fully connected layer. These layers are the last layers of the convolution neural network, and the inputs corresponded to the flattened and one dimensional matrix. And we can see the image in this like neural input neurons, and we can see the first hidden layer. And every hidden layer have the neuron has a local feed. And we have image shown here like CNN architecture. Uh, in this image shows that CNN used for determining if a person is wearing a mask or not. That detects that if a person wearing mask and or not. Like we have first the input is that we have to give 100 into 100 pixel image of a person's face. So then the next step is the convolution layers. Like these two layers have that apply filters to image to detect the features. This work mainly to detect the features, and the third step is like flatten. The flatten is that converts the 2D picture maps from the convolution layers into a 1D vector. And dense layers is dense two layers where the final classification is made, and the first has 64 neurons and the second has the 2 neurons, and these representing the classes like with mask and without mask. These architecture is explained total what is the function going in this. And next my friend will continue.
Now let us discuss about workflow. In this research paper, we used 1378 images to detect masks from images. We have taken images from different sources. Photos are captured from webcam, mobile phone. We are resizing image into 100 into 100 as we need common size for all the images before applying it. Before applying it to neural network, we are here resizing each and every images. This process comes under data preprocessing and augmentation. Under classification with CNN, we have two types: convocation layer with max pooling, convocation layer with average pooling. The max pooling method depends on samples. The main aim is to reduce the complexity of input representation, but with an average pooling process, the image inside the matrix area is used in average pooling. The starting process of a CNN model is sterics. The image matrix is flattened and trained after that. In this research paper, we are using 80% of the data in training and 20% for testing. After calculating, in order to get the output, we have to perform performance evaluation. Under performance evaluation, it consists precision, recall, accuracy, and F1 score. There are formulas for each and every evaluation. For precision, it is TP by TP plus FP. For recall, it is TP by TP plus Fn. For accuracy, it is TP plus Tn by TP plus Fn plus Tn plus Fn. And for Fn score, it is precision into recall by precision plus recall. Here, TP means true positive, FP means false positive, Fn means false negative, and Tn means true negative. Now let us discuss about Haar cascade frontal face algorithm. First, we have to know what is Haar cascade frontal face algorithm. Haar cascade is a detection algorithm which is used to identify the face in an image. In this algorithm, there are four stages: Haar feature selection, creating integral images, AdaBoost training, and the last one is cascading classifiers. Now, let us discuss each and every stages. The first stage is Haar feature selection. In this feature, we have edge feature, line feature, and four rectangular feature. The hard feature tend to be two valued features, that is white and black. The white represent high value and black represent low value. The second feature is creating integral images. In the second feature, it is used to creating integral images. We will use hard feature on each and every image. We use this feature in different direction as shown in the images. Uh, this is the black filter and this is the white filter. As we already discussed, the white represent the high value and black represent the low value. Now, the third feature is AdaBoost training. In AdaBoost training, the hard features has two values. This one, the blue represent the positive and the cream color represent the negative. So this means the blue one corresponds to 1 and the green one corresponds to -1. We will add pixels in blue area and subtract from cream area. It depends upon the color. And the last feature is the cascading classifiers. The fourth feature, which is cascading classifier, it is differentiate the positive as well as negative images. The positive images. The positive images are those which are having faces, and the negative images are those which are other than the faces. So it will go under the different stages: the stage 1, stage 2, stage 3. After that, we will get an output. We will consider whether it is a face or it is an other object. In this research paper, we have used her cascade classifier, which is basically a machine learning object detection algorithm. Now, the thoughts and reflection will be continued by my friend.
Now let us discuss thoughts and reflections for this project. The first one is ethical considerations. By raising such type of technology can raise the privacy concerns in the public spaces. And it is also an important to know that how the data is being collected by the system. And the second one is scalability and the real world application. This project is designed in such a way that it can detect the face mask in the controlled scenarios, and it should be designed in such a way that it should detect the face mask in the public crowded areas where multiple faces appear in the different angles and in the different lighting conditions. For that, it should consider the updatation of the algorithm or the additional training data to handle the complexities. And the next one is to improve the efficiency of the algorithm. For that, it should consider the cost of the running CNN in the real time using more efficient convolution neural networks like mobile net or efficient net, which will improve the speed without losing the accuracy. According to us, for a better system, adding a new feature can improve the system to learn by its own. Instead of having the reprogrammed system, the system should be designed in such a way that it should be updated on its own, which helps us to detect the face mask in the different angles where the system detects the different face masks. In conclusion, the expected outcome of this research paper is it can detect the face mask of a person, he or she wearing a face mask or not, with an accuracy of 94.49. This paper helps in ensuring the safetiness by themselves. And here we can see the result. If a individual is wearing the mask, it is displayed as the green anchor around the face. If the individual is not wearing the mask, it is displayed a red anchor box around the face. By clicking on the camera button, it detects the face mask of a person, and it is all, and this also works in the videos also. And these are our references for our project. Thank you.